Hey everybody, this is Larry. This is me going with Cube 4 of the weekly contest 311 Summer Prefix Scores of Strings. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this is actually almost, to be honest, a textbook application of the prefix tree, or sometimes known as a trie, spelled T-R-I-E. Here I end up taking about a little over 5 minutes, but I actually didn't have any template codes. I wrote it from scratch. I imagine if you're very hardcore, you probably have some of it pre-written, though I will also say that a lot of the top people don't have it pre-written in the sense that excuse me, they know how to write it in like 6 lines of code. So I always write it out just because it's easier to debug. But yeah, the idea is that, okay, if you, well, the number one thing I would say is learn about the prefix tree or a trie. Yeah, if you don't know how a trie works, this is not going to be that helpful, and just read up on it or watch another video on it. But the idea is that for each trie, you construct a prefix trie, and let me actually bring up the drawing board so I could visualize what I'm doing a little bit better. Hang on. So yeah, so basically you have a trie, and while going into the basics, you just have let's say a root node, and then you have these edges, let's say A, B, and so forth, right? C, D, I don't know, right? B again maybe, and then maybe another C, and then another A, right? And here at each node, oh, I kind of messed up actually. I meant the node is on the thing is on the you could actually think about it either way, but this is the way that I prefer. Sorry for the weird drawing, friends. But yeah, but then the idea here that is at the node, we also contain the count, because what is that? What does this do exactly, right? What this is saying is that, okay, at this node, what is this node from root, right? This node from root is A. Let's do another node that's a little bit maybe more confusing. Let's say this node. What is this node? This is BCC, right? And basically what we're doing here is that for each creation of the word, we increment a count. So then first we go, okay, this is 1, this is 1, this is 1, and then now this is 2, this is 2, this is 2, and then so forth, right? Let's say now we have BCB, and then now this is 3, this is 3, this is 1, right? So then here we know that we're giving ourselves a setup such that when we traverse it again, we kind of see all the number that has that number prefix and so forth. And that is coincidentally, or maybe by design, exactly what the question needs. So yeah, because that's basically what they're asking. I'm gonna go over the code. As I said, I thought maybe ordering matters, but then just looking at the problem, it does not, because you can count itself and all these other things. So yeah, so first I add, for each trie, each word I add trie, and of course the most of this is standard to a trie. The only thing that I add a little bit different is that for each node I increment by 1, right? So this is a count on node, and then after that's all done, we start with, for each word, we try to find how many prefixes in total there are. And this is actually what they, the sum of the scores, and the score is just calculated this way. So yeah, I mean, I don't really have anything magic here. It's that for each character, we go, okay, how many, maybe that's another way of thinking about it, is that for each word, for each prefix, we go, okay, how many words uses this prefix, ... And then now 2 characters of the prefix, now 3 characters of the prefix, ... And that's basically all this is doing. And that's pretty much it, really. If you want to see my thought process or my coding process, you could watch my, the next portion of this, which you can see me solve it during the contest. You'll see how I kind of make some adjustments, because I actually misread some of this problem as well. I just thought, well, 2 things. One is that I thought it's the sum of this, which is actually a very trivial fix. The other is that I thought it had to be whole words and not just the prefix or like you don't count all the prefix or all the prefixes. So you could kind of see how I evolved it here, in case you're wondering. So a lot of misreading in this contest, but that's pretty much it. So what is the complexity here, right? Well, for this try, for each character in every word, we actually just traverse this twice, right? Once for the add, and then once for the find. We do a traversal here and a traversal here. So that means that we look at each character twice exactly, and therefore it is linear. Linear in the size of the input, which is the total number of characters in the input. That's all I have with this one. Let me know what you think. Let me know how you did, and you can watch me solve it live in the contest now. Two silly mistakes already, just on misreading and silliness. Very rusty. All right, focus. Let's finish it. Number of words such that word is a prefix of word sub I. It's just a regular try problem, it seems like. Yeah. Do I have a try implementation? Let's save some time here. Nope. Okay, fine. Oh, this doesn't bite me in the butt. I think I did that wrong because it's not supposed to be add. What am I looking? Oh, because yeah, I'm supposed to return a list. That's why. Every message is a little cryptic. That's not right, is it? I misread this one. A B C A B. 2 strings of the prefix a. Oh, okay, so I did misread this one, but that's fine. This is easy to fix, hopefully. I was also wondering where 0 counted, but I guess that's fine. Hopefully no silly mistake, but because I kind of YOLO this one. And that's kind of sad because I would have finished. Hey, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and an explanation. I'll see you later. Stay good, stay healthy, to good mental health. Goodbye and take care.